Ever feel like you're just drowning in information, like you're trying to swim through this massive wave just to find the key stuff?
Oh, absolutely. It's not about finding information anymore, is it? It's about finding the right information, the stuff that actually matters.
Exactly. And well, that's what we're diving deep into today. Retrieval augmented generation, or RG. It sounds technical, but think of it like giving AI a super smart research assistant.
That's a great way to put it. Yeah, we're going to unpack what ARGI really is, why it's such a big deal right now, and, how it actually works under the hood.
And we've pulled together insights from, well, all over. Microsoft's Cloud Blog, Amon Rag, Hugging Face, Label Studio, Devorials, Project Pro, Acorn Labs, AWS, even a Reddit thread had some good points.
A real mix. So the goal today is to give you a really clear picture of ARGI, what makes it tick, the upsides, and how people are actually using it out there.
Okay, let's jump in then. What exactly is retrieval augmented generation?
Right. So at its core, RAG is a technique to make large language models, LLMs, smarter by feeding them relevant external information before they generate an answer.
So it's not just relying on what the LLM already knows from its training.
Precisely. Instead of just using that massive but static data set it was trained on, it gets like a timely update with context specific to the question.
So it's like giving the LLM a quick briefing document tailored to my specific query.
Spot on, yeah. Think of it as that super efficient research assistant that pops up just when the LLM needs it. It's really about combining information retrieval, finding the relevant stuff, with the LLM's power to generate text.
Okay, I think I get the basic idea, but why do we even need this? Aren't these LLMs supposed to be incredibly knowledgeable already?
They are incredibly powerful, no doubt. But they do have limitations. For one, like we said, their knowledge is based on their training data, which is basically a snapshot in time.
Right, so it can be outdated.
Exactly. It might not know about the very latest developments or, really niche topics. And maybe more importantly, because they generate text based on patterns, they can sometimes, make things up. We call it hallucinating.
Hallucinations. Okay, that sounds a bit worrying, especially if you're relying on the answer.
It absolutely can be, yeah. Particularly if accuracy is critical. RE helps tackle this by grounding the LLM's answer in actual retrieved information current, often domain-specific stuff.
So it forces the LLM to base its answer on facts it's just been given.
Pretty much. It shifts from potentially just generating plausible text to using verifiable information, which, makes a huge difference in trusting the output.
Okay, that makes a lot of sense. Instead of guessing based on old data, it's using fresh facts.
Exactly. And that leads straight to the big benefit. You get answers that are more accurate, more relevant, and just generally make more sense in the context of your question.
All right, I'm sold on the why. So how does this actually work? Walk me through the steps.
Okay, so generally you can think of it in about 4 main stages. Sometimes people break it down a bit more, but 4 covers it. The first crucial step is indexing. Some call it the collection phase.
Indexing,
Yeah.
like creating a library catalog for the data.
That's a perfect analogy. You're basically curating all the documents, the articles, the data, whatever you want the LLM to potentially draw from. This could be text, structured data, you name it.
And how do you make all that stuff searchable, especially if it's different kinds of data?
Good question. That's where chunking comes in. You break down the larger documents into smaller, manageable pieces, or chunks.
Okay, smaller bits. Then what?
Then comes a really clever part. These chunks are fed into something called an embedding model.
An embedding model. Okay, that sounds a bit technical.
It is, a bit, but the core idea is really powerful. It's a type of AI model that converts those chunks into numerical representations. We call them vector embeddings.
Numbers that represent meaning.
Essentially, yes. These vectors capture the semantic meaning. Think of it like words or phrases with similar meanings end up having mathematically similar vectors, even if the words themselves are different.
Huh, okay. Translating meaning into math. Clever. What happens to these vectors then?
They get stored in a special kind of database called a vector database. Examples you might hear about are things like Qdrant, Pinecone, maybe pgvector. These databases are specifically designed to store and efficiently search these high-dimensional vectors based on similarity.
So it's a database that understands meaning, not just keywords.
Exactly. So step 1 recap. Documents get chopped into chunks. Chunks get turned into meaning vectors by an embedding model, and those vectors go into the vector database.
Got it. Docs to chunks to vectors to vector DB. What's step 2?
Step 2 is retrieval. This starts when you, the user, ask a query in just plain language.
Okay, so I type my question.
Right. And then your question also goes through that same embedding model we used before.
Ah, so my question gets turned into a vector too, in the same meaning space.
Precisely. Now the system takes your query vector and searches the vector database. It's looking for the document chunk vectors that are most semantically similar, closest in meaning to your question vector.
Using things like cosine similarity, I think I read.
Exactly. Measures like cosine similarity or Euclidean distance. It finds the vectors that are the closest match in meaning and retrieves the actual text chunks associated with those vectors, usually the top few most relevant ones.
So it's finding the pieces of information that are conceptually related to my question, not just matching words.
That's the key. That's semantic search. Okay, step 3 is about consolidation and augmentation.
Consolidation and augmentation.
Yeah, so consolidation, some sources like Aim and Rag really highlight this, might involve filtering out redundant chunks, maybe re-ranking them to put the absolute best matches first, perhaps even summarizing them slightly.
Tidying up the search results, basically.
Sort of, yeah.
Mm.
And then comes augmentation. This is where the system takes those refined, relevant chunks of information and combines them with your original question.
Okay, so it bundles my question together with the best evidence it just found.
Exactly. It creates an enriched prompt. It's basically giving the LLM your question plus the necessary context to answer it well.
And that leads to the final step.
Step 4, generation. This enriched prompt question plus context is finally passed to the large language model itself, like a GPT-4o or a Llama 3.
And the LLM uses that context to write the answer.
Yes. Because it now has that relevant, retrieved information right there in the prompt, it can generate a response that's coherent, contextually informed, and crucially grounded in the data we provided, not just its internal knowledge.
Wow, that whole process, indexing to retrieval to augmentation to generation, it sounds incredibly powerful. So let's talk benefits. Why are people so excited about this? What does RAG actually do for us in practice?
Oh, the benefits are pretty significant. One huge one, mentioned by Microsoft and Acorn, is getting current and up-to-date knowledge. LLMs are trained on past data, right? RAG pulls in info in real time.
Which is critical for things that change fast, like news or maybe stock information.
Exactly. Or customer support details, travel advisories, insurance policy updates, things like that. If the information needs to be fresh, RAG is a massive help.
Okay, makes sense. What else?
Contextual relevance. Because it retrieves information specifically related to your query, the answers are much more tailored. And Microsoft also points out a data privacy angle here.
How so?
Well, your proprietary data, say your company's internal documents, stays in your secure database. It's only accessed for the query. It doesn't have to be mixed into the LLM's training data.
So the sensitive info stays put. That's important.
Definitely. Think about getting internal policy help or technical support based on specific company manuals. Highly relevant and keeps the data secure.
Very valuable. Any other major benefits?
Yes, a really big one. Reducing those hallucinations we talked about.
Right, the making stuff up problem.
By grounding the LLM in external verifiable sources, RA makes the answers much more accurate and reliable. And often you can even see which source provided the info, source attribution.
So you can check its work. That builds trust.
Absolutely. Crucial in fields like law, medicine, finance. Imagine a financial advisor getting insights from SEC filings with citations back to the specific documents.
Yeah, I can see that. What about cost? Is this expensive to set up?
Well, compared to retraining a massive LLM, RAG is often much more cost-effective. Microsoft and Acorn both mention this. You're leveraging your existing data without that huge retraining cost and effort.
So you use the data you already have, which is cheaper and faster to implement.
Generally, yes. Faster deployment, too. Think of an e-commerce site using its existing product docs and FAQs to power a support bot via RAG.
Makes perfect sense. Anything else on the benefit list?
One more key one. User productivity. By getting people precise, relevant answers quickly, it saves them loads of time digging through information themselves.
Less time searching, more time doing.
Exactly. Think about automating research tasks or compliance checks. KPMG, for instance, has a tool called Comply AI that uses this kind of approach.
Okay, so faster, more accurate, more relevant, cost-effective, boosts productivity. Yeah, I can see why there's buzz. Are there different flavors of RAG? Different types?
There are. You can categorize them a bit. The most common is probably text-based RAG, just using semantic or keyword search on documents.
Like we've been mostly discussing.
Right. Then there's graph-based RAG. This uses knowledge graphs, those networks, Showing relationships between entities for retrieval can be powerful for complex queries.
Ah, using the connections between data points.
Exactly. And logically, there's hybrid RAG, which tries to combine the best of text and graph approaches.
Makes sense. Mix and match.
And then the really cutting-edge stuff is multimodal R. This aims to bring in not just text, but also images, videos, audio, pulling information from different kinds of data.
Wow. Understanding pictures and sound, too. That opens up a lot.
It really does. It's a big area of research. And, to make it less abstract, Hugging Face actually has a pretty neat example of building a simple R system.
Oh, yeah. How simple are we talking?
Well, simple enough, you could potentially run it on your own machine using Python and a tool called Olama, something that came up in that Reddit discussion too, people playing with local setups.
Right. Olama for running models locally.
Exactly. Their example basically takes some cat facts, creates embeddings, stores them in a basic vector store in memory, and then when you ask a question about cats,
It finds the most relevant cat fact vector.
precisely, it embeds your question, finds the closest cat fact vector using cosine similarity, grabs that fact, adds it to your prompt, and feeds it to a local language model, like a small llama model, to generate the answer based on the retrieved fact.
Huh. So you can actually build and run a basic version yourself.
That's cool. Okay, so where is this actually being used? What are the big applications out in the world?
Oh, lots of places. According to Project Pro and Acorn Labs, customer support chatbots are a huge one. Think Shopify's Sidekick or Google Cloud's Contact Center AI. They use RA to pull answers from knowledge bases.
Right, giving accurate, up-to-date support makes total sense.
Uh-huh.
Then there's document summarization and search. Quickly getting the gist of long reports or finding specific info. Bloomberg uses it in finance. Google has Vertex AI search.
Cutting through the noise in massive documents. Yeah, I can see the value.
Definitely. It's also big in medical diagnostics and research, helping doctors by pulling relevant info from medical literature. IBM Watson Health has explored this space.
Wow, potentially life-saving applications there.
Potentially, yes. Also things like personalized learning systems, fraud detection. JP Morgan Chase uses AI here, e-commerce recommendations like Amazon does, and just general enterprise knowledge management, helping employees find answers in company data, like at Siemens or Morgan Stanley.
It seems like almost any area with lots of information could benefit.
Pretty much. General question answering, building smarter conversational AI, even content generation where you need factual accuracy.
Okay, it sounds amazing, but surely it's not perfect. What are the challenges or limitations?
No, definitely not perfect. There are challenges. Label Studio and Acorn point out that the retrieval step itself can sometimes go wrong. It might pull back stuff that's irrelevant or incomplete, or maybe even just wrong.
So the research assistant can sometimes grab the wrong files?
Kind of, yeah. It could be because the original data wasn't chunked well, or the embeddings weren't quite right, or the retrieved snippet just doesn't have enough context on its own.
So garbage in, garbage out still applies to some extent.
It can, yes. Which is why there's a lot of work on improving things. Techniques like ranking and re-ranking models to better prioritize the retrieved chunks.
Trying to surface the best results more reliably.
Exactly. And hybrid search, combining that semantic vector search with traditional keyword search, can sometimes boost precision. Plus, lots of focus on better chunking strategies and using feedback loops, maybe even human review, to fine-tune the system.
So constantly refining the process based on performance.
Right. And looking beyond just text, that multimodal R we mentioned, figuring out how to pull information from PDFs, images, tables, audio, that involves things like OCR, understanding layout, using multimodal embeddings. It's a complex.
Definitely sounds complex. I also saw mention of agentic R. What's that?
Yeah. Agentic ARG is kind of the next level. It's about giving the ARGA system more autonomy. Like it can observe, reason, and then act.
Act? How?
Well, it might decide its first retrieval wasn't good enough, so it refines its query and searches again. Or it might use external tools like a web search engine or an API to gather more information or validate what it found. It's more iterative, more dynamic.
So a more proactive research process built into the AI.
In a nutshell, yes. But of course, all this comes with other challenges too, like RE is fundamentally dependent on the quality and availability of that external knowledge.
Right, the data sources have to be good.
And there's computational overhead. Doing all this retrieval and processing in real time takes resources. And as always, privacy and compliance are huge concerns, especially with sensitive data.
We touched on privacy earlier, how RAG helps by keeping data separate.
Exactly. That's a key point from the Microsoft Cloud blog. Unlike fine-tuning where your data gets baked into the model, or RAG keeps your proprietary data in its secure database, accessed via strict controls only when needed for a query. It doesn't become part of the model itself.
That's a really critical difference for businesses worried about their data.
Absolutely. And people are always working on optimizing RAG better prompt engineering, using metadata with embeddings, hybrid search, recursive retrieval, smarter query engines, testing different chunk sizes, fine-tuning the search algorithms. It's a very active area.
It really sounds like it, a field that's moving incredibly fast.
It absolutely is.
Yeah.
So just to wrap up our deep dive here, RAG is fundamentally this powerful technique for boosting LLMs by connecting them to external knowledge.
Right, making their answers more accurate, more relevant, more reliable across all sorts of uses.
And the big wins really are that access to current information, the contextual understanding, cutting down on those hallucinations, potential cost savings, and definitely boosting productivity.
And it's still evolving with things like multimodal and these agentic approaches pushing the
It's
boundary.
constantly evolving, yeah.
It really makes you think, doesn't it, about your own work or areas you're interested in. Where could this kind of grounded, informed AI make a difference? How could you use it to cut through the noise?
It's a great question to ponder. We're really just starting to explore the full potential here for, better decision making and faster knowledge discovery. Definitely worth keeping an eye on.